We present BrickCraft, a compositional framework for long-horizon robotic assembly of interlocking bricks. Given a digital design, BrickCraft first rehearses the assembly process in simulation through physically grounded reasoning. It then translates this virtual plan into real-world execution by composing learned visuomotor skills, turning digital designs into physical creations. BrickCraft adopts an assembly-by-disassembly approach to synthesize a physically feasible plan. Crucially, each step is anchored to a reference brick within the partial assembly. This decomposes open-ended assembly tasks into modular primitives characterized by the relative spatial relationship between two bricks. These primitives are encoded into skill descriptors that condition the visuomotor policy to steer the robot's assembly behavior. At each assembly step, BrickCraft bridges the virtual plan with physical execution through the situated manual, which highlights task-relevant entities in real-time observations to provide explicit spatial guidance for the visuomotor skill. We collected human demonstrations across diverse assembly tasks for skill training. We demonstrate that the situated manual guidance not only facilitates efficient skill learning, but also enables seamless generalization to unseen structures. Finally, by composing these spatially grounded skills, BrickCraft achieves fully autonomous, long-horizon assembly across various brick designs.